equation solvable for p. What does it mean? So suppose this is a nth degree differential first order ordinary differential equation, and if possible, we factorize it into n factors of p, say p minus f1, second factor p minus f2, so on, p minus fn equals to 0, right? Where f1, f2, fn, etc. are functions of x comma y. Okay, so suppose it is possible that the given differential equation of n degree, it can be factorized as linear factors of p, n factors of p. And what next? We take individual factors separately, right? And these individual factors, and we solve them. And these individual factors are nothing but the first order and the first degree ordinary differential equations. Okay, so we solve each of these first order and first degree differential equations. Okay, and suppose the solution for the first equation is, say, y minus say some function of x plus c, right, equals to 0. Second one is, say, y minus f2 x plus c, and so on. So the final solution of the given higher degree equation will be, we will write these individual solutions as y minus f1 x plus c into y minus f2 a function of x plus c, so on, y minus x and function of x plus c equals to 0. And this will be the general solution of the given higher degree differential equation, right? We should ensure that in the same, we will take the same arbitrary constant in all these n solution, because this is first order differential equation. So its general solution should contain only one arbitrary constant. So let us take a couple of examples to understand how to solve these kind of equations. And we have to solve this equation. Solve p square y plus p x minus y minus x equals to 0. Now, we already know p stands for dy by dx. So, this is a first order differential equation because only p, that is dy by dx, occur in this equation. And because of p square factor, this is a second degree ordinary differential equation, right? Now, let us factorize it into the linear factors of p, and because it's a quadratic equation in p, if we consider this as a as a simple algebraic equation in p, so this is a quadratic equation. It means it will have two linear factors as with p as unknown variable, right? So let us rewrite this equation as p square y plus px minus py minus x equals to 0. Should keep in mind that we have to factorize it into the linear factors of p. Okay, so uh, let us combine these two terms where p is common, so this becomes, inside the bracket is py plus x. Let us take minus 1 common, so this one is py plus x equals to 0, and take out the common factor py plus x, so we have py plus multiplied by p minus 1 equals to 0. So we have factorized the given differential equation into linear factors of a p variable. Fine. So next, we find the solution of these individual factors. So let us take this first factor is py plus, and the equation becomes 0. We already know p stands for dy by dx, so we write it as dy by dx plus x equal to 0. And we can see that this one is a first order and first degree differential equation. Let us solve it. So we can write it as dy by dx equals to minus x, and this is turn out to be a separable form. Rearranging the differentials, so we can write it as dy equals to minus x dx. This is separable form, right? First order, first degree separable form. So integration of dy equals to minus integration x dx, and we have this arbitrary constant c. So this becomes y equals to minus x square by 2 plus c. The solution of this equation is y equals to minus x square by 2 plus c. Let us take another factor, and the second factor is p minus 1 equals to 0. We read p is dy by dx minus 1 equals to 0. Again, this is first order and first degree ordinary differential equation. We rewrite it as dy by dx equals to 1, converting it into separable form. This one is dx. So this is separable form, and we integrate it. Integration of dy integration dx plus c. We should ensure that we take the same symbol for the arbitrary constant. So this becomes y equals to x plus c. Now the solution of first factor py plus x is, we can rewrite it as y minus x square y plus x square by 2 minus c equals to 0. And the second one is y minus x minus c equals to 0. So these are solution of these individual factors. So as discussed earlier, the general solution of the given second degree ordinary differential equation, we will write it as y plus x square by 2 minus c multiplied by y minus x minus c equals to 0. So this is the way we solve a higher degree ordinary differential equation, first order higher degree ordinary differential equation, subjected to the condition that it can be factorized as a linear factors of p variable. Let us take one more example, and where we are solving, we have to solve this equation. This one is cube minus plus 2x p square minus y square p square minus 2 y square p equals to 0. This one is a third degree first order and third degree ordinary differential equation, third degree because of p cube. Okay, so let us try to factorize it as linear factors of p variable. Now, because this is cubic in p, it means it will have three linear factors in p, right? So let us bring these two terms together and these two terms together. So p square is coming out common here. So we can rewrite it p square. It becomes p plus uh, 2x, right? So this one is 2x. P square has been taken out, and minus from here I can we can take y square p. So we have y square p, and inside the y square p, inside the bracket will be p plus y square p has been taken out. So this is p plus 2x equals to 0. Now p plus 2x is common factor in these two terms, so we can write it as p plus 2x into p square minus y square equals to 0. Now this one is linear factor in p. This one is not a linear factor in p. I beg your pardon. This is y square p. So let us convert it into linear factors involving p variables. So we can take a p out of p common from these two terms. So further simplifying, p plus 2x p common, and we have p minus y square equals to 0. So we have resolved this given the uh, third degree equation by treating this as an algebraic equation with p as a non-variable into three linear factors of p. Now let us take these factors one by one. First factor is p equals to 0, p equals to 0, and this implies dy by dx equal to 0, right? And further simplify it, dy equals to 0. Again, this is separable form, so integral dy equal to integral 0. This implies y equals to c. So this one is the first, this is a solution of factor p equals to 0, right? The second factor is p plus 2x equals to 0, writing dy by dx for p. So this one is dy by dx plus 2x equals to 0. Again, we can convert it into separable form. So we have dy over dx equals to minus 2x. So this is dy equals to minus 2x dx. Separable form, first order and first degree solution method integrating both sides. So this one is minus 2x dx plus arbitrary constant. We have to take the same arbitrary constant which was taken for first factor. This implies y equals to minus 2x squared by 2 plus c. 2 is cancelled out and we got the solution as y equals to minus x squared plus c. So this one is solution of the factor p plus 2x equals to 0. Now the third factor, the third uh, factor is p minus y square equals to 0, writing dy by dx for p, dy by dx minus y square equals to 0, writing it in separable form. So dy by dx equals to y square, which can be written as 1 by y square dy equals to dx, right? Integrating, so separable form, 1 by y square dy integration dx, and this one is cosine arbitrary constant c. We can write it as y raised to power minus 2 dy equals to integration dx plus c. Integration of y raised to power minus 2, y raised to power minus 2 plus 1 over minus 2 plus 1 equals to x plus c. So this is minus y raised to power minus 1 equals to x plus c. It can be rewritten as x plus 1 over y plus c equals to 0, bringing this minus y raised power minus 1 to right hand side, right? And so this is the solution of third factor. So we have for each individual factors we have three solutions. One y equal to c for this factor p, y equal to minus x square plus c for factor p plus 2x, and x plus 1 by y plus c equals to 0 for the factor p minus y square equals to 0. Finally, writing the solution of the original equation, we have to combine all these three solutions. So it will be y minus c, we can write it as y minus c equal to 0. So the first solution factor will be y minus c. Second, we take from here, this can be written as y plus x square minus c. So the y plus x square minus c multiplied by third factor will come from here, x plus 1 by y plus c. Okay, and finally this is equal to 0. So this one is the solution of the third degree, first order, third degree of the ordinary differential equation, which was solvable for P. Thank you.